and I've loved using IEnumerable for the lazy behavior, but I'm moving away from IEnumerable for this one simple reason. Alright, so today we're going to be talking about IEnumerables in C#, and specifically we're going to dive into how they're used as return types. I'll explain how their usage can lead to lazy behavior, but also how it can lead to eager behavior as well. As we go through some examples together, I'll elaborate on why I've liked using them in the past and also why I'm trying to move away from them going forward. Before moving on, just a quick note to check that pinned comment for a link to my free weekly newsletter. There's an exclusive article every week and early access to some of these videos that you see on YouTube. Alright, let's jump over to Visual Studio. Alright, on my screen I just have a really simple application that's going to be looking at this number getter. And this number getter, we're going to check out the implementation in just a moment, but I want to walk through what this high-level program does. As you can see, there's a stopwatch here, and what we're going to do is check out an implementation of a method that uses IEnumerable, and we're going to check out the lazy version of that. We're just going to write that time out to the console and then basically do the exact same thing, except we're going to look at an eager implementation of the same method. So let's go check out what this number getter does. On my screen, we can see both implementations within the number getter class, and we have the lazy implementation at the top and the eager one below. To explain what I mean by lazy is that we have IEnumerable as the return type, but we're making it what's called an iterator. And it's an iterator because we're using this yield keyword syntax here. If you're not super familiar with IEnumerable and how we can transform it into an iterator by using the yield keyword, a super quick rundown is that once we use the yield keyword inside of an IEnumerable, it essentially converts it into what's called an iterator. And that means that the only type of return that we can have inside of here is one that we yield back out. We can also yield break to stop an IEnumerable, or an iterator in this case. The yield keyword is what provides us the lazy behavior behind this IEnumerable implementation here. So if we go to jump down to the bottom version here, which is the eager one that I have on the screen, the similarity is that it's still an IEnumerable as the return type, but it's not going to be lazy. And it's not going to be lazy because it's just going to return all of the values at once, 1, 2, and 3, inside of an array. Now you might be asking why I have a thread.sleep on here, and that's because when we go to run this, I want to walk through some different examples of this behavior, and I'm just using a thread.sleep to give us a little bit more of a delay so we can see what's happening as we run the code. What I want you to keep in the back of your mind is that if we're considering loading some data from a data source, like a database or even reading things from a file, there's going to be a little bit of a delay when we're doing that compared to just having stuff in memory. So as we're going through this, consider that we're getting some records from a database or reading some files, and the different records that we're pulling back all have a little bit of a delay when we're doing that. So this is going to be exaggerated because hopefully reading a single record from a database is not going to take you a full second, and that would mean in this case a whole 3 seconds to get 3 records from a database, but we're exaggerating it just so that we can see it. In reality, there will be some amount of delay, hopefully very small, but still something that exists. Let's go run this application and see the difference in behavior for lazy and eager. Alright, the results are done and they're really interesting. If we see, the lazy implementation took 0 milliseconds to run, and the eager one took a full 3 seconds and a little bit of overhead of 135 milliseconds on top of that. But how is it possible that the lazy one was 0? How did it take no time at all to go run the lazy one? Well, I tricked you a little bit, and I'm sorry. So the reason that it didn't take any time at all for the lazy implementation is because we never evaluated the iterator. And I'm going to explain that a little bit more when we go back to the code, but that's a really key point that's going to come up a little bit later, and why IEnumerable as return types, especially with iterators versus not, can get a little bit weird. So keep that in mind as we go back to the code. So the issue that we have lies right here on line 6, where we say get numbers lazy. And again, if you're not familiar with IEnumerables and iterators, this is something that you probably never would have noticed. So I don't blame you if you were surprised by it taking 0 time at all. But because this is a lazy implementation, because it has the yield keyword, therefore making it an iterator, we need to evaluate it in order for it to actually process the time that it takes to get that data. Simply materializing the results here by doing toArray, doing a for each loop over it, or even toList will in fact force this to evaluate. And that means if I go run this now, we can go see the difference in the time it takes. All right, the results are in, and now the lazy is also taking about 3 seconds. We can see that these extra few milliseconds here at the end are a little bit different, and it's really hard to tell if this is just some overhead with the stopwatch or something else, but later on we'll see that when we go to benchmark this, we'll have some differences in performance. But that's going to be in a follow-up video, so stay to the end and we'll have more videos in this series to explore this. The point here is that when we're forcing the lazy to evaluate, that means that we're in fact getting similar performance to when we're doing it eager. We have to pay that penalty of the thread.sleep that I put in for each of those records, and because there was 3, each being 1 second, that's why we get that time that we see. So now that you've seen this lazy behavior, I just want to talk about historically why I've really liked working with IEnumerable. This goes back to working in a product that had a lot of records that we were pulling into a user interface for users to explore, and one of the challenges was that we had developers that were effectively forcing an entire data set to be materialized and then tried to put that into the user interface. And when I say entire data set, I mean hundreds of thousands of records or millions of records. So this was of course problematic because we couldn't pull all of that data into the user interface all at once. So yes, of course we could have added different implementations of how we were fetching the data under the hood, but more on that in just a moment. And I want to talk about why using IEnumerables for us really made things work. We saw in the most recent example that by putting toArray on the lazy version of the IEnumerable, which is an iterator, it forced the evaluation of that enumerable. But there were many cases in the application I was working in where people just wanted to test if data was there, or they wanted to get the first one out of a data set. And because they were looking at an IEnumerable, they said, well, it's getting the data. If I just ask it for the first one, it should be good to go. Let's go back to the code and use something like any or first, these link methods that we have, and see what happens between the lazy and the eager versions. So back in the code here, I'm just going to replace this toArray with any, and down here I'm also going to do the same thing because we're only interested in checking to see if there's anything inside of this enumerable. I mentioned that you could also use first. These will have similar behaviors in this conversation, so I'm not going to demonstrate both, but what we'll see with any is going to be similar to first. As we can see, the runtime is very different for lazy versus eager here. They're both using any on the result that we're pulling back, but when we see the lazy one, to check if there's any, it only took us 1 second. When we did the same thing on eager, it took us the full 3 seconds. So why does that happen? Well, the answer lies in this yield keyword here. So because this implementation, the lazy version, is an iterator, because it has a yield keyword, all that had to happen to prove if there was anything inside of this IEnumerable was simply getting to this first yield. We had to wait that full 1 second to be able to yield return the number 1, but once we did that, the enumerable was able to terminate. We didn't have to go through the rest of this implementation to be able to see if there was anything inside of it. In the eager variation, because I wanted to make these comparable, instead of waiting 3 seconds individually to get each item, I just waited the full 3 seconds. And because we have to do that to even see this collection come back, that means we're paying the full performance penalty right up front. So thinking back to the example that I was mentioning in the product I was working in, the developers were calling methods that were fetching data, and because it was materializing full sets of data to be able to pull back to the user interface, they were paying a big penalty, not only in the runtime to be able to get those records, but also in terms of memory, because the entire collection had to be materialized. In this simple example, we're not even looking at the memory footprint. However, in the first example up here, just by having the yield, we were able to effectively skip all of this code from running once we got 1 yielded back. So I did mention a little bit earlier that in my example from where I was working, yes, we could have implemented new methods to go be able to check things like any or to get the first record from a data set. We could have implemented more unique specific things for those scenarios. And I've loved using IEnumerable for the lazy behavior, but I'm moving away from IEnumerable for this one simple reason: API readability. In both of these examples that we looked at, if you're the caller of the method that we have, you don't have an ability to know if it's going to be eager or lazy, and that means that you don't know the performance implications of calling that. You need to make assumptions about it. So do you always assume that it's going to be eager? Do you always assume that it's going to be lazy, or do you have some other way to know if it's going to be one or the other? The reality is you can always find out if you have access to the code, but that means that as developers we have to pay this tax. We have to go dig into the code to look deeper to see what's happening. So if you see IEnumerable as the return type, you can't really stop there. You have to dig deeper to understand fully what's happening under the hood. If you keep digging deeper and seeing method calls that also have IEnumerable, you gotta keep going until you finally get to the base scenario where you can see, am I materializing a full list and returning it, or am I yield returning at some point? Because if you're yield returning at some point, the entire call stack all the way up now becomes lazy. You're dealing with iterators. However, if at any point you're materializing some return value that's coming back up that call stack from an iterator to a collection, or from a collection to a collection, you're not going to have a lazy implementation. It's not going to be an iterator because there's no yielding back individual items. And if that sounds kind of complex, it's because it is. But it's all buried behind the same API. To you, as the caller of these methods, all that you see is IEnumerable of some type, and then the method name and the parameters. You have no idea under the hood if it's lazy or eager until you go to run it or until you go to dig into the code. Now, a lot of the stuff that I share on my channel, I'm trying to explain to you these different programming concepts, but at the same time, I'm trying to layer in real practical software engineering guidance. And for me, there were too many headaches, too many instances of people not understanding this behavior with lazy versus materialized lists, that it made it really hectic for people to do the right thing. So yes, IEnumerable did afford us to be able to do things like first or any and not materialize full data sets that were ridiculously big, but the other side effects that we didn't look at in detail are things like people accidentally lazily evaluating things on the UI thread. It was an IEnumerable the whole way up, and they finally materialized it on a blocking UI thread. Oops. Or another great one is that when you have a lazily evaluated IEnumerable, so an iterator in this case, you could be fetching data from a database. When you do things like calling any or first on it and it's not materialized and stored, what ends up happening is that people end up calling the same thing in different spots. And it's the same pointer, that same function pointer to this iterator, and they go run the database query multiple times because it was never materialized and stored. These are all characteristics of a lazy IEnumerable, and they can be used to your advantage, but when you don't know what you're dealing with, they can have a lot of problems that you weren't expecting. So we did see that in both cases we can have an IEnumerable that's lazy, and we can have an IEnumerable return type that's also eager. And I mentioned right near the beginning of this video that we do need to look at benchmarks for both of these, because the runtimes that we were seeing, they were comparable, but they're at the millisecond granularity. I'm doing some benchmarking kind of in the console with a stopwatch. It's not super granular, and we're not looking at the memory footprint either. So we will want to look at the benchmarks, but before we look at the benchmarks, I really think it's important to look at using IEnumerable or other collection types both as parameters and return types. So when that video is ready, you can check it out here next. Thanks, and I'll see you next time.